Next we have to cover the topic scalar quantities, vector quantities, as well as distance, displacement, speed and velocity. So first is scalar and the vector quantity. Scalar quantity. A quantity which require only magnitude but no direction, and their complete representations are called scalar. This example of scalar quantities are distance, speed, work, mass, density, etc. These are the example of scalar. Scalar can be added, subtracted, multiplied according to the algebraic rules. So indirectly we can say that scalar quantities are those quantities which require magnitude only and follow algebraic law of addition, subtraction and all. So these are the scalar quantity. Example are distance, speed, mass, energy, work. These all are the example. Now next is vector quantity. Vector quantity means those physical quantities which require magnitude as well as direction for their complete representation. These are called vectors quantities, and these quantities follow vector law of addition. For addition, they follow vector law of addition. So indirectly we can say that vector quantities are those quantities which has magnitude, direction and they follow vector law of addition. So magnitude, direction and follow vectors law of addition. These are called vectors quantities. For example, vector quantities are displacement, velocity, acceleration, force and so on. There are number of examples. Now sometimes there are some quantities which has magnitude as well as direction, but even though we consider that quantities as scalar quantity, not as vector quantity. Sometimes there are some quantity which has direct magnitude as well as direction, but even though these quantities are considered as scalar. Why so? Because they follow algebraic law of addition. So for a quantity to be vector, it must fulfill magnitude, direction and also follow vector law of addition. So if a quantity follow all these three things, then it's said to be a vector. Otherwise, if it has two follow points, that magnitude and direction, but do not follow vector law of addition or follow algebraic law of addition, in that case this is a scalar quantity. So next is distance and displacement. First, distance. It's a scalar quantity. Displacement is a vector quantity. Now, distance, the length of actual path traversed by an object is called distance. Scalar quantity, it can never be zero and negative. It has always which value? Positive value. It's always have positive value and its unit is meter. Apart from it, displacement, it is always the shortest distance between initial and final position of an object during the motion. Displacement can be positive, negative and zero. It's a vector quantity and unit of this is again meter. So indirectly or in shortly we can say what? For if we want to do the comparison of distance and displacement, what we can discuss here? First of all, it's scalar quantity. It's a vector quantity. One point is same for both. Its SI unit is meter and its SI unit is also meter. It's always the actual path, but it's always the shortest path. or indirectly we can say it's a path between initial and the final position. Initial and the final position. Next, distance. Distance and displacement. Next point is distance is always positive, where displacement can be positive or negative. Distance is never 0. This is not equals to 0 anytime, but displacement can be 0. It can be 0. Distance is always greater than or equals to displacement. Distance is always greater than or equals to displacement. Let explain this thing with the example. Suppose this is point, this is origin. On this side this is positive axis, on this side this is negative axis. Suppose initially object is at point A, O, then it's moved to the point A by path 1. By path 1. So this path 1 actually describe what? Distance traveled by the object. It describe distance traveled by the object. So path 1 is actually representing distance traveled by the object. But if we have to define the displacement, as we know displacement is always the shortest distance between initial and final position. This position is what? This is initial position. This is initial position, and this one is final position. So a shortest part between them is a straight line. So this is actually representing what? Displacement. This is representing what? Displacement. So from here it is clear that displacement is smaller as compared to the distance. Distance is more, displacement is less. So displacement is less than distance. Now second example. Suppose again origin, body first move from O to A, then from back A to O. Body first move from O to A like this, then back to A to O. Now distance covered is path 1 plus path 2. Path 1 and path 2, but displacement is, initial point is this, and again final point is also this one. Final and initial both coincide. So in this case net displacement is 0. Net displacement is 0. So distance is not 0, but displacement is 0. Now if a object move from O to A first, then from A to point C. So path 1 and path 2 represent the sum of both represent total distance, but first from O to A, then from A to O. This cancel out, then from O to C. This is negative 1. So displacement is negative. So initial point is this, final is this. This is initial, this is final. So initial and final distance is negative here. Suppose an object move first is at point A, then it moves to the point B, then it moves to the point C. First from A, then finally move to C. This is initial point, this is final position. Now if this is initial, this is final, the total distance is path AB plus BC, but total displacement is initial to final. This is displacement, but this plus this is distance. So distance is always greater than displacement. Now next is speed and velocity. First of all, what is speed? Formula of speed is distance traveled by time taken, and speed is a scalar quantity. So the time rate of change of position of an object in any direction is called speed of object. Formula is distance upon time taken, and its unit is, so speed is distance upon time taken. If it's distance upon time taken, then its unit is meter per second. Meter per second. Now next is, and it's a scalar quantity. Its dimension, if we talk about dimension given here is wrong. This is m0 l1 t minus. These are the dimensions of it. Now next is, speed is of two type, uniform speed and non-uniform or variable speed. Uniform or non-uniform or a variable speed. If an object cover equal distance in equal interval of time, then it's said to be uniform. But if it's cover unequal distance in equal interval of time, then it's said to be non-uniform or a variable speed. Non-uniform or a variable speed. Next is velocity. Velocity, it is the rate of change of displacement by time taken. It is the rate of change of displacement of an object in a particular direction. It is the rate of change of displacement in a particular direction. That speed was in any direction, but displacement is in a particular direction. Unit is again meter per second. Dimension is again wrong here. That is m0 l1 t minus 1. It's a vector quantity, have both magnitude and direction and follow vector law of addition. And velocity, just like displacement, velocity can be positive, negative or zero. Displacement can be like velocity can be positive, negative or zero. Now velocity is displacement upon time taken upon time taken. So if displacement is positive, velocity is positive. If displacement is negative, velocity is negative. And if displacement is zero, then velocity is zero. But speed is always positive. Speed is always positive. Just like uniform and non-uniform speed, velocity can be uniform and non-uniform. If displacement, if a body cover equal displacement in equal interval of time, then it's said to be uniform velocity. Otherwise, it's said to be non-uniform velocity.